Hello students, today we are going to start a topic called number system. This topic is important for all the students who are preparing for competitive exams like GATE, and it is also important for students who are doing their diploma or polytechnic because this chapter is there in their curriculum. Okay, so many of you must be having it in your curriculum, or if you are appearing for various competitive exams, this topic is an important and very easy topic to follow. Okay, so today we will discuss about what is number system. Okay, then we will discuss about the types of number system, and finally we will see the conversion. Okay, in my next lecture we will continue with the other topics included in the number system. Okay, so let us quickly understand what is number system. When we talk about number system, it is basically a set of values. What is number system? It is a set of values. Now, what does this set of values do? It represents something. Okay. Now, what is this something? It can be anything like mass, height, weight, you're counting. How do you, when you count a particular thing, suppose you're counting the number of candles. So how you're going to represent it? Using a particular number system. Okay. Now, when we talk about a computer system, it also understand a certain type of number system, which we call as binary number system. A computer only understands binary number system. Okay, which we will be discussing what is binary number system and everything. So basically you just need to understand for now that what is number system. It is a set of values which represent something. Okay, an amount. Okay, so let us begin with the types of number system. What are the various types of number system? So coming to the types of number system. Now, when we talk about the types of number system, there are basically four types of number system. Okay, the first one is binary number system. Binary number system. Now, when we talk about binary number system, remember the term binary represent two digits. How many digits? Two digits, that is 0 and 1. These are the two digits which is there in the binary number system, and that is why the base or radix of a binary number system is 2. Why? Because it has how many digits? Two digits. It has two digits. Alright. Now, the next type of number system is octal number system. Now, what are octal number system? Again, if you see the name, it will tell you that it has 8 digits. How many digits? 8 digits. What are the 8 digits? 0, 1, 2, 3, 4, 5, 6, 7, 8. I'm so sorry. It's already 8 till 7. Okay, so we'll erase all this. Yeah. So how many digits it has? 8 digits. What are the 8 digits? What are the 8 digits? 0, 1, 2, 3, 4, 5, 6, 7. If you count 1, 2, 3, 4, 5, 6, 7, 8. There are total 8 digits. Okay. So if there are total of 8 digits, what will be the base or radix of octal number system? 8. Right. It will be 8. Now, the next kind of or type of number system is decimal number system. Decimal number system, we use it in our everyday life. Okay, so what are those digits of a decimal number system? The digits are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Alright, so there are a total of 10 digits, and that is why the base or radix of a decimal number system is how much? It is 10. Clear? Now the last type of number system which we will be discussing is hexadecimal number system. Hexadecimal number system. As the name says hexadecimal, it is clear that it has a total of 16 digits. Okay, so what are the 16 digits over here? Let us start from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. But actually these numbers are not represented as numbers in a hexadecimal number system. The number 10 is represented as A. Number 11 is represented as B. Number 12 is represented as C. Number 13 is represented as D. Number 14 is represented as E. And number 15 is represented as F. So these are the digits of a hexadecimal number system. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. A, B, C, D, E, F. These are the digits of a hexadecimal number system. Okay, so since it has 6 digits, what shall we write about the base or radix of a hexadecimal number system? It will be 16. All right. So I hope the types of number system is clear to all of you. In case if you're having any doubt or any query, you please mention it in the comment section so that I can help you with it. Okay. Now let us go to the next topic, that is conversion. Okay. Now, when we talk about conversion, it means converting any number system into the other. Okay. So, first we will see how we can convert a decimal number into other number systems like binary, octal, hexadecimal. First, in this lecture, we will see that. Okay. So, our topic would be from by decimal to others. All right, clear? So let us see one by one. So we'll start with number 1, from decimal, conversion from decimal to binary. How to do this conversion? Okay, I'll be teaching you from very basics. Okay, so just understand, you'll be able to do it. So suppose I take any decimal number. Now when we are taking a decimal number, what do? We write it with a base of 10. So suppose I'm taking a decimal number 25. So 25, how do I write it? Like this, base 10. And when we write a binary number, how do we write it? Within bracket, base 2. Alright, so we have to convert this decimal number into a binary number. So what do? Write this number 25, and since you want to convert it into a binary number which has a base 2, so divide this number each time with 2. Okay, so if it is 25, what you can write? 2 12, 2 12s are 24, and you have a remainder of 1. So I'll write the remainder here. Again, 2 6 are 12. But here we don't have any remainder. That is, the remainder is 0. 2 threes are 6. Again, the remainder is 0. 2 ones are 2. So the remainder is 1. Now this 1 can no more be divided by 2. So we leave it as it is. Now what will be the number we are getting? We will go from bottom to top. Okay. So the number will be 1, 1, 0, 0, 1. 1, 1, 0, 0, 1. This will be the corresponding binary number of the decimal number 25. Okay, let us see another one. Number 2. Okay, number 2 as in, we can write it as, this is A, let us see number B. Okay, so for B, let us take another decimal number. Suppose let us take 100, and we have to convert it to a corresponding binary number. So how do we do it? Again, we'll take the number 100 divided with 2 each time. So let us do one thing. We'll do it here so that we get enough space, right? So yep, 100, and we'll divide it with 2. So 2 50s are 100, so remainder is 0. 2 25s are 50, again the remainder is 0. 2 12s are 24, the remainder is 1. 2 6s are 12, the remainder is 0. 2 3s are 6, the remainder is 0. 2 1s are 2, the remainder is 1. Again, how do we go? From bottom to top. So what will be the number inside this? It will be 1 1 0 0 1 0 0. Alright, so this will be the corresponding binary number of the decimal number 100. I hope it is clear to all of you, right? So you guys need to practice a lot of these conversions to get it clear. Okay. Now, sometimes we have a decimal point along with the decimal number. So if there is any such decimal thing, so we will be discussing that also. Okay. So we'll do that later. First, let us see the simpler things. Okay. So from decimal to others, if we have a simple decimal number, whole decimal number, this is how we go about the conversion. All right. Now let us see. This was from decimal to binary. Now let us see how do we do decimal to octal. Decimal to octal. So how do we do decimal to octal? Let us take few examples. Suppose we have a number 98. Okay, this is a decimal number 98 because it has a base 10. You have to convert it to an octal number. Now if we have an octal number, the base will be 8, right? So what are we going to do? Let us take this number 98 and divide it with 8. Okay, so we'll divide it with 8. Now if you divide it with 8, you know 8 12s are 96. So the remainder will be 2. Again, can we divide 12 with 8? Yes. So 8 ones are 8. Remainder is 4. So again, bottom to top. If we go bottom to top, what do we get? 1 4 2. So 1 4 2 is the octal number. Okay, corresponding octal number of the decimal number 98. Okay, let us see one more example. Okay, let us take another number. Suppose let us take a 3-digit number 127. Okay, we have to convert it to an octal number. Okay, all right. Let us do that quickly. Okay, what do? We take number 127 and divide it with 8. Okay, so again, you see here, if you divide it, then 8 15s are, if you calculate, I'll just show you the calculation. 15 into 8. If you know the table, still I'm showing it to you. Okay, 120, right? Okay, so if it is 120, the remainder will be, what will the remainder? 7. Okay, so 8 15s are 120, the remainder is 7. Now again, if we take this number, 8 ones are 8, again the remainder is 7. Now no more, we can go ahead. So again, from bottom to top, 177. So what are we going to write here? 177. So this is the corresponding octal number of the decimal number 127. Okay. Do you want to see one more? Let us see one more. Mm, let us take another number. Suppose let's take a small number, 56. Simple number. Okay. 56 base 10. We want to convert it into an octal number. Okay. What do? Again, we divide 56 with 8. So 56 divided by 8. We know what oh, it will be easily divisible, right? So we can do like that. 8 sevens are 56. 8 sevens are 56. So the remainder is 0. Okay, so we can simply write 770. So the octal number of 56 is 70. Okay, so what do we write the answer as? 70. Okay, is it clear? Now we'll come to the third type of conversion, that is decimal to hexadecimal. So number 3, decimal to hexadecimal. I hope my handwriting is not too bad and it is readable. Okay, so decimal to hexadecimal. How do we do that? So we need to first take a decimal number. Suppose we take the number, let's take a short number, 49. Okay, base 10. What are we going to do? We are going to convert it to a hexadecimal number. So hexadecimal number has a base of 16. So how do we do the conversion? We have an idea. What do? We have to divide it by 16 each time. So let us take the number 49 and divide it by 16. If we divide the number 49, we know 16 threes are 48. So you have a remainder of 1. Alright. So what do we write it? The answer would be 31. Okay. This actually, when we are writing this now, this one, the bottom one, it is known as MSB. Okay, the full form of MSB is most significant bit. Okay, and this is bottom, and the top one is LSB. What is the full form of LSB? Least significant bit. All right. So MSB, the bottom one, and the top one is LSB. All right. Now let us see another example where we convert a decimal number to a hexadecimal number. Now let us take a big number this time, maybe a 3-digit or a 4-digit number maybe. Okay. So we have to convert it to a hexadecimal number. So 1228. If we divide it with 16, then 1676 will give us a remainder of 12. Okay, you please try to do it on your own. 16, because of the calculations, if you do the calculations, that's important. Again, you'll get a remainder of 12. So do you remember when we have a remainder 12 in hexadecimal system, then how do we write it? We write it as C. We write it as C. Shall I show you that? Okay. Here you see. When we have a number 12 in hexadecimal number system, we write it as C. Alright. So here we are going to write them as C. And then we will go from MSB to LSB. Bottom to top. Okay, so what answer are we going to get? 4CC. So this is the hexadecimal equivalent of this decimal number. Okay, I hope it is clear to all of you. So this is how we do the conversion of decimal into decimal number system to other types of number system. Okay. So we will keep this till here, and in my next lecture, we will see how we convert a binary number to a decimal number, octal number to a decimal number, or a hexadecimal number to a decimal number. Alright, so I hope you understood what I taught, and I hope this video was helpful. If you have any problem, any query, you can mention it in the comment section. Thank you so much. Do subscribe to the channel and share the video with the needful.